Hello everybody, this is Mr. McAllen again, and hopefully you had a chance to watch the earlier video of the chain rule done the traditional way. What I'm going to do now in this video is, hopefully in a shorter amount of time, show you how to do the chain rule using what I like to refer to as the onion rule, or done from the outside in. Let's pretend for a minute that you have a function. Y is a function of x, but it's really a function of y is a function of u, which is a function of v, which is a function of x. So it's got multiple layers deep of a composition of functions. So when you do the derivative and you want to take the derivative of y first, you would do the derivative of y with respect to u, evaluated at u, multiplied by its derivative of its inner function, du with respect to v, because v is its inner, evaluated at its inner function, multiplied by dv with respect to its inner, which would be x. And if you look at the notation, if your goal is to get the derivative of y with respect to x, all of these terms, as before, cancel, and you're just left with dy dx. So let's get started and show you how it works. You have to recognize we have an outer function and an inner function. So when you say you want to find dy dx, for this one, you simply take the derivative of the outermost function. That would be the derivative of sine, evaluated its inner, times its derivative of its inner, which would be 3. And that would be all you'd have to do. You'd have to just move that coefficient in front. And that would be your derivative of dy with respect to x. Now you move on to the next function, where we have 3 layers. So we should rewrite this, just mentally maybe think about it, where you have sine of 3x plus 1, and remember the squared is the outermost function. So when we do this, the derivative with respect to x would equal, first we want to bring the 2 down in front, and that's now 2 to the first power. That's the 2 power becomes the first power, but remember we evaluate the outermost function at its inner, and now we work on the next innermost function. So the derivative of that is going to be cosine, evaluated at its inner, and then we multiply that by the derivative of 3x plus 1 at its inner. Well, there is no more inner, it's just the derivative of 3x plus 1 is 3. We bring the coefficients out in front. So we'll have 6, the sine of 3x plus 1 times the cosine of 3x plus 1. And that would be how we'd find the derivative of that function using the onion rule. And the last one is the same one we had before, where you have x cubed being multiplied by 2x minus 4 to the 4th power. So we'll just write out, again, f is equal to x cubed, g is equal to 2x minus 4 to the 4th, f prime is equal to 3x squared, and g prime is equal to, now we can just apply our onion rule to this simple function. I bring the 4 down in front of 2x minus 4, raise the 3rd power. Now they've taken the derivative of the outermost function. I'm going to now take the derivative of the inner layer, which would just be 2. And my final answer for this will be 8 times 2x minus 4 quantity cubed. So now assembling my derivative should be relatively easy, because it's just f prime g minus g prime f. And then I have, so f prime g would be 3x squared times g, which would be 2x minus 4 to the 4th, plus g prime f, which is 8 times 2x minus 4 cubed, times f, which will be x cubed. And now I'm at the same position I was with the earlier problem, and if I want to find the derivative and simplify, I could probably, since I have some time, I could simplify this, because I'm going to take an x squared out of both, and I'm going to take a 2x minus 4 to the 3rd out of both, leaving behind a 3 plus I have an 8x. Oops, I have to make sure I do this correctly. I have a 3 left behind. I have a 2x minus 4 left behind. Plus, when I look at this term, I'm going to just have an x left behind, an 8, and I've already pulled out the 2x minus 4 cubed. So this would be the next step for simplifying. I have x squared, 2x minus 4 cubed, and when I distribute the 3 through this, I have 6x minus 12 plus 8x. And then I end up having x squared, 2x minus 4 to the third, and this would be 14x minus 12. I would end up pulling a 2 out, and I have a 7x minus 6. And that would be the simplest form of my derivative. And I know I went a little bit over time. Well, look at this. It's only 6 minutes to do this part with the onion rule, where it took almost 10 minutes for the other one. So anyway, I hope this was helpful, and please leave some comments on the YouTube channel for anything that you think might be of help in the future. Thanks again, and I look forward to your comments.